Welcome back to The Explainer. Today, we're laying out the minimalist engineering blueprints for debugging optimized Solana deployment scripts, and we're going to do it without losing our minds in the process. Look, if you've been working on Web3 deployments for any amount of time, you know that keeping things completely stable as they scale is just an absolute necessity. We need a highly systematic, rock-solid way to track down the inevitable bugs that creep in.
You know the feeling, right? You've likely just spent weeks, maybe even months, making your scripts blazingly fast. You've got your parallelization perfectly tuned, your caching is dialed in. But here's the catch. That optimized speed inevitably introduces a whole new kind of headache. A massive increase in the risk of subtle, incredibly chaotic race conditions. We're essentially trading slow execution for a much trickier problem, where precise ordering can just easily break the whole system. So, to fix these high-speed crashes, we're going to follow a precise engineering schematic today. 1. Fast scripts, new bugs. 2. The flight recorder method. 3. Reproducing the crash locally. 4. Fixing and tagging commits. And finally, 5. The final debug report.
Let's jump into Section 1. Fast scripts, new bugs, the trade-off of speed. Okay, so here is the absolute core trade-off we're dealing with. When you apply batch parallelism to something like account creation on Solana, your wall clock time drops beautifully. It's fast. But your surface area for errors spikes massively. It's a direct correlation. The faster the script executes, the more likely it is that tiny, seemingly harmless changes will completely break the sequence your entire deployment relies on.
Moving right along to Section 2, the flight recorder method, auditable script changes.
To actually bring order to all this chaos, we've got to fundamentally shift our thinking. We need to treat each and every Git commit as a permanent, auditable record. Think of it literally like a flight recorder on an airplane. When your deployment script inevitably fails, and it will fail, you don't panic. You don't just start guessing. You calmly query the recorder to see exactly what went wrong. Actually, investigating that crash requires 5 methodical, almost mechanical steps. We reproduce the failure, we narrow down the exact commit that introduced the regression, we apply the fix, we verify it with automated checks, and then we record the solution. It's a highly disciplined loop. But, well, it all starts with setting up the right laboratory environment.
Which brings us to Section 3, reproducing the crash locally. Local controlled laps.
Before we can even think about digging into our flight recorder, we absolutely must recreate the exact crash conditions. And we do this entirely locally. Because, let's be real, trying to reproduce a bug hundreds of times on mainnet, that is just a fantastic way to drain your wallet with transaction fees and completely destroy your sanity waiting for wallet approvals. A local environment strips away all of that friction.
So how do we start? We simply spin up a fresh, local solana-test-validator and we make sure to use that reset flag. This is crucial, because it guarantees a completely blank slate for reproducible execution. We're making sure absolutely no external network noise interferes with our investigation. It's a totally clean room.
Then, we actually run our failing deployment script directly against that local validator. And notice here, we are capturing all of the output and the error streams into a timestamped log file. Why? Because this allows us to meticulously inspect the precise runtime behavior, line by line, right after the crash occurs.
Now, if the issue turns out to be one of those really tricky, elusive parallel race conditions, we isolate it. We build a tiny harness script, usually just a simple loop. By intentionally lowering the batch sizes or forcing much tighter timing loops, we trigger the error way faster than waiting for a full deployment run to fail. This perfectly sets us up to confidently use git bisect and find the culprit.
All right, Section 4, fixing and tagging commits, isolating your fixes.
So, we've found the bug, and now comes the fun part. It's time to actually fix the code. But we have to do it without destabilizing our main project branch. We immediately isolate our workspace by branching off, creating a short-lived branch specifically designed just for iterating on this single fix. This keeps the main deployment perfectly pristine while we perform our surgical repairs.
Once you've nailed down that fix and applied it, you have to use strictly formatted commit messages and tags. No exceptions here. Whether it's a bug fix or a new feature, the format must be rigid and totally consistent. Because honestly, a beautifully structured tag is exactly what makes this entire project's history readable for the next engineer who has to query the flight recorder down the line.
And finally, Section 5, the final debug report, documenting the fix.
Look,
A proper debug report isn't just busy work. It's a highly useful, critical artifact. It clearly and cleanly links 4 pieces of vital information: the exact steps someone needs to reproduce the failure, the specific root cause commit that broke it, the exact remediation code we applied, and the automated smoke checks we used for verification. This report is your definitive, undeniable proof of a solved problem.
So you might be asking, why does this highly structured approach matter quite so much? Because this exact discipline is what allows you to confidently reverse catastrophic mistakes in the future. It makes incredibly complex integrations and big environmental changes entirely auditable and, most importantly, reversible. Without this structured approach, you aren't really engineering anymore. You're just guessing.
So, I want to leave you with this final thought to really chew on before you sit down to write your very next deployment script. When it inevitably crashes, because we all know it will, are you going to be flying blind? Or is your version control already a perfectly structured flight recorder just waiting to give you the exact answer? Get that infrastructure set up today. Thank you so much for hanging out with me on this explainer, and I'll catch you in the next one.